Okay, problem number 1 on assignment B from this week. This was the question where they gave you a bunch of student-teacher ratios for the 10 schools with the highest proportion of students meeting standards and the 10 schools with the lowest proportion of student meeting standards. So they were comparing these schools who could meet the standards and not meet the standards and how their student-teacher ratios shaped up. So they asked me to do a dot plot and then comment. So there's my little dot plot. Try to put them together so you can compare a little bit. Very straightforward dot plot here. This is the dot plot for the schools that had the highest percentage meeting standards. These are the ones for the lowest. In terms of comparison, just quickly looking, it looks like the average for both is somewhere in that same ballpark for sure. But the main difference, you could do some little math real quick to find that average, of course, too. But this one's way more spread out, right? The one with the highest proportion is way more spread out than the other ones. Second part of that question asked you to, it says any statistical test that is used to determine whether the mean student-teacher ratio is the same. So if we were going to do a test, would not be appropriate. Why not? And the main reason it's not appropriate is because they're not simple random samples of two different populations. We handpicked these. Remember, these were the 10 schools with the highest proportion. These were the 10 with the lowest proportion. So in essence, they become populations. They're not simple random samples, so we can't do any comparison. Problem number 2. Pretty quick, pretty straightforward. This was the one where they gave you 4 graphs, A, B, C, and D, that all came from, there were 500 samples selected from a known population, and the true parameter was 75 for all of these. The first question says, which ones appear to be unbiased estimators? Remember, an unbiased estimator means you should get what you expect to get. So if the population has an average of 75, your sample should have an average somewhere around 75. They're just simulations. If we get all of the samples, they would be exactly 75. So if you look, about 75, not about 75, about 75, about 75. So A, C, and D are unbiased because they all have the same average as the population average, about 75. Part B said, which one, A or B, would you choose to be a better estimate of the population parameter? Hopefully that's straightforward since A is unbiased and B is not something that would happen with B, who knows? So A would be better because it's reason, because it's unbiased. And then which ones of C or D would be better? Well, C and D are both unbiased, so now the question is which one do you want to use? And C is a little bit better because it has less variability. It's not as spread out. So it'll probably give us a better gauge of what's really happening in that population. So that's it for 1 and 2.